Tonight we're very honored to have with us Mr. Evan Kwisnek. Evans currently works as a systems architect and engineer at Everwatch Solutions Incorporated, where he collaborates with a team of system engineers, software developers, testers, and systems administrators to modernize, design, and deploy performant and secure distributed systems. Evan previously served in the U.S. Army and has worked within the Department of Defense since 2004 in various roles of intelligence systems technician, network engineer, systems administrator, and technology instructor. He is a cloud native and open source advocate, and tonight he'll introduce us to the world of engineering for cloud native security and policy. So with that, I'd like to turn the podium over to Evan.
It's a real big honor to speak to you tonight, so I'd like to thank the Incose Chesapeake chapter for inviting me out to speak tonight. I was having a look at the other lectures preceding mine this year, and I see a lot of systems engineering process, a lot of sort of strategies for doing systems engineering through a lot of sort of codified processes. We're going to try to depart from that a little bit tonight, and I'm hoping that this is going to be a surface level and a practical exploration of some, as the title implies, some cloud-native security and policy. And I'm hoping that I can inject some humor and be informational at the same time. So again, thank you for tuning in. So who am I? As Clinton said, I'm a veteran. I was in the U.S. Army. I was a technology instructor. I taught a great course, a network engineering course for the Department of Defense for a number of years, and that was very fulfilling. I was a network engineer, system administrator, system engineer, and currently working as a system architect or a platform architect more appropriately. I just have some contact information there, so if you ever want to reach out with questions, there's my personal email and also my GitHub if you want to see some terrible code that I've written. So some things in the news. Here are just some little headline-grabbing pieces of information that I was able to grab during my research. And some of it is sort of shocking, right? It's shocking, but it's not so if you work in cyber, if you work in the cloud-native space. And you see here, through 2025, 99% of cloud security failures will be the customer's fault. Now, in this context, the customer means the people using the infrastructure, Amazon Web Services, Google Cloud Platform, Linode, Hetzner Cloud, you name it. We're talking about the engineers, system administrators, developers using that cloud infrastructure. It's going to be their fault, if there's a cloud security failure. And I think that follows pretty accurately with the trends we're seeing today. And again, through 2025, 90% of organizations that fail to control public cloud use will inappropriately share sensitive data. Now that's actually through the course of normal business logic. My application A is talking to application B, and I'm sharing this data because I need to move it from a database to another application for processing, and I'm going to inappropriately share that, meaning I'm not going to encrypt it, I'm not going to secure that connection. That's what we mean about inappropriately sharing sensitive data. And I think one of the big ones, we'll skip the respondents here, but the big one that I think hits close to home for a lot of folks in this area is the 2014 breach of OPM, the Office of Personnel Management, where 22.1 million personnel records were exfiltrated from the Office of Personnel Management. That's fingerprint data, social security numbers, background check information, right? So the stakes are very high when we're talking about cloud-native security. We're talking about doing business in the open internet, exposed to all sorts of threats, right? And the last thing is that same PlugX vulnerability, it's called PlugX, that's the attack or the vulnerability that was leveraged for OPM, that still is in use today. That didn't just disappear. So we didn't just say, okay, in 2014, we figured out how they got in, we fixed that bug, and we can just move on because we'll never get hit by that again. Well, in 2021, as recently as December 2021, that same vulnerability was used in another breach. So it's not gone, certainly. So really to just introduce the talk after we get through those sort of, wow headlines to establish the seriousness of what we're talking about. What we really want to level set on is the fact that these modern system architectures, these modern distributed systems are moving from traditional on-premise data center environments to the cloud, or to some hybrid form of the cloud. Either you're somewhat on-prem, or you're on-prem, you're hybrid, you're edge, you're in the cloud, you're fully in the cloud. And so now that we're exceeding the bounds of what we traditionally thought of as the data center, how are we going to adjust the way that we do security engineering? How are we going to adjust the way we do information security engineering? And so tonight we want to focus on those challenges, right? Some practical solutions to those challenges, to both the engineering side, but then also the policy side as well. So a little bit of a digression first before we get into, what is a traditional large system architecture and what is a cloud native architecture. I think it's important to talk about computing inversions, right? This is sort of a phrase that I've kind of coined, but it's a familiar concept, and that is that the evolution of computing technology, Moore's law, transistors getting smaller, computing getting cheaper, it leads to lots of developments and advancements in the way that we employ that compute power. So we started with mainframe computers, which then gave way, all that miniaturization and power efficiency gave way to the personal computing revolution. And then from the personal computing revolution, as the commoditization of silicon and these pizza box servers started emerging, you saw a move to the cloud, where most of the computing is not done on my eMac at home, or my Apple Lisa at home, or my IBM at home. It's rather being offloaded to the cloud. My Google Drive, my Microsoft OneDrive, these sorts of things became very, very popular. And so that's what we consider today to be the cloud. When someone says the cloud, obviously now it's a ubiquitous term, it's an overloaded term, but this pay-to-play infrastructure was kind of our second inversion, or what we know as the cloud. And I put a trademark there. It's definitely not trademarked, but the cloud, right? And we're actually amidst, right now, a third inversion, really. It's happening as we speak, and that is a move to what's called the edge. And I put that in quotes because that's kind of becoming the new cloud. And what we're seeing is a lot of computing power, again, being miniaturized. The ARM core CPU architecture is enabling a lot of this. This miniaturization and power efficiency is pushing a lot of businesses to go from the cloud, or the data center, or the colo, all the way to the edge, where the data is being processed. And what I mean by data is IoT devices, your Amazon Alexa, your Siri, these little devices in your home. They're getting more and more powerful, and these companies like Amazon are saying, well, why are we backhauling all of this data from these sensor devices, these IoT devices, to the cloud to be processed, when I can just do analytics at the edge? I can do my analytics closer to where the data is actually collected, so I can turn that data around faster and provide a better customer experience, right? So that is this third inversion, and we're kind of in the midst of that right now. I think less in the personal space or the home space. You see this in 4G, 5G, the push for telecom providers to have these edge compute containerized and virtualized network functions all the way at the tower. So instead of your routers and switches all being back at some, again, data center or colo, you now have a small data center at the base of your cell tower that's doing all your computing and all of your virtual and containerized network functions for that cell infrastructure. So again, that's more infrastructure we need to secure because it's in different places now. It wasn't in the cloud, now it's physical and I can touch it, it's back at the edge. So how do we secure that infrastructure? That's going to be an open question, I think, for years to come. So these shifting sands, this changing landscape as these computing inversions occur over these periods of years, what does this bring about, right? It's a lot of upheaval. It's a lot of change to the way the system is deployed. And so therefore, I can't take antiquated or what I thought was a best practice in the previous generation of computing and apply it to the current generation of computing. Because in many cases, and in almost all cases we'll see, it just doesn't work that way, because the landscape has changed so dramatically. So let's talk a bit about traditional large-scale system architectures. Traditional large-scale system architectures, what am I referring to? I'm talking about data centers, okay? You are a business, you are a Acme Corporation, crunching data, your customers' data. Where is that data being crunched? In your data center, on computers, on server systems, networking equipment that resides inside the four walls of your establishment, your facility, your corporate building. This is a traditional large-scale system architecture. Let's say it's the size of a football field, but it's all, again, inside of the confines and the secure confines of your facility. And the motto was, if I can keep the bad guys out, I'm good, right? You draw a box around your system, and you put the little fire logo on there and say, this is my firewall. And you say, okay, if I keep everyone outside that's bad, and all the good stuff is happening inside, then I'm good, right? That's all I need to worry about, because I got the guards at the door, I got my physical security, and I got my firewall, so I'm kosher. So we have a trusted perimeter, trusted access, secure data, right? All of these things are, I want to say, taken for granted at a certain point. How can when you onboard a new employee and they want to access your systems, how do you do that? Oh, they go through HR, they go through the sysadmins, they get an account, they have access to your system now. Well, they went through the proper channels because they're on the inside of your wall, right? They're inside your building, so they're part of that trust network that we say, okay, you're allowed to have access, and if you're outside of my trust network, you can't have access. But I say all of this in service of really looking at, was it so simple? I think now we think that the cloud is so complicated and so complex because it's difficult to get your mind to form the picture of the scale, right? I can't draw a box around the cloud. I mean, I could, but it would be a very large box about the size of the Earth, right? But this is just an example. I ripped this straight off of Network Bachelor, but this is a data center infrastructure reference architecture. And that reference architecture, excusing for a moment the top right portion, you see a public cloud portion there, but that's just a tiny box in an otherwise very large and complicated set of boxes. It's not important that you can read all of this. In fact, I hope you can't read all of this to sort of drive home the point that in a traditional large-scale data center reference architecture, I didn't just have computers and then walls. Right? I did not have some simplistic architecture that was super easy to employ, super easy to engineer, super easy to secure, and super easy to administer. This is, a lot of people like to play that game of the old was simple, the new is really complicated, and therefore you need to buy our product. Right? Our whiz-bang security silver bullet product is made for the cloud, and the old data center stuff was super easy. I would challenge that notion and say that the old stuff was hard too, right? A lot of us who did that type of work, systems administration, network engineering, security engineering, we had a difficult job as well because these systems, as they get bigger, they grow exponentially in scale and complexity as well. I do have a little funny graphic. So my friend here, as an aside, I found that in making these PowerPoint presentations, the new Microsoft PowerPoint has these clip art humans, cut out people of randomly doing gestures, and that was the end of it because I needed to put them everywhere. So this gentleman is very happy with his data center architecture, and he's just this is a Private Snuffy or Mr. Snuffy, the system administrator who's just been given the keys to the kingdom here and said, hey, this is your responsibility now. So he's screwed, yes, indeed. Comic Sans and all. All right, so we've talked about traditional or data center, traditional large-scale system architectures in the context of computing and data processing. As we move to the cloud, right? I'm just going to say the cloud now because to try to qualify that and say, well, I don't really mean the cloud, it would take all night. So let's just say as we migrate to the cloud, remember that second inversion from PC to the cloud, what is actually happening here? What happens to those same problems that we know weren't trivial in the data center, but now how do they change and how do they potentially grow? Scale problem, as I mentioned. You think you have 10,000 servers, that's a problem. Yeah, that's a 10,000x problem. But now, if those 10,000 servers are in 14 availability zones across 7 regions in Amazon Web Services, in different parts of the world, managed by different folks, and being accessed every day by people in those individual countries, and actually being serviced at the infrastructure layer by completely separate individuals. Your virtual machine in AWS or EC2 is actually, as they say, it's not the cloud, it's someone else's computer, right? Oh, it's in the cloud. No, it's on someone else's computer. And that computer is physically somewhere in a data center. And so at the sort of bottom turtle level, turtles all the way down, at that bottom turtle level, you're worried about the actual hardware that machine is running on at the end of the day. Again, disparate networks, availability zones, regions, all of these places throughout the world that, instead of having a homogeneous local area network or a set of virtual local area networks, and that's separated from your wide area network, by that magical firewall silver bullet device, you now have these disparate networks, geographically disparate, different security levels. You might have a secure LAN versus your public-facing LAN that your applications, your customer-facing applications actually run in. And then you have the problem of access. You have more hands in the pot, as I say on the slide. You have infrastructure engineers, you have site reliability engineers, you have DevOps engineers, you have developers, you have security auditors, you have customers, right, and clients for your data or for your web service or whatever your business is. All of this is happening to your infrastructure at all times in the cloud. Okay, so I can't draw my box around the infrastructure anymore. I can't draw that pretty box around my servers and apply that firewall. So moving on to to revisit the idea of lots of folks accessing your systems. The question of who are these people? Who is accessing my system? I know I have these trusted system engineers and these system administrators over here, and because they're a part of my trusted team, and I onboarded them. But who else is accessing the system? How can I audit that? How do I even know that? There's a concept of observability. How can I even observe that someone is accessing my system? You might have, if you have a large enough company in a cloud-native landscape of today, you might have, I say, dozens of developers and engineers. That could be thousands. Amazon, Google, Netflix, the FANG companies, they employ over 10,000 engineers that work in basically every country in the world. And so, again, back to that scale problem. Now we're talking about human scale, big scale of the number of folks accessing that infrastructure. And then on top of that, that's just the people, the human element. But you then have automated processes. You have non-person entities, right? These automated systems, part of your CI/CD, your continuous integration and continuous delivery tooling that is accessing with credentials all of these systems every day to do, important tasks like application upgrades, security upgrades, these types of things. But that's, again, access to your systems that you need to monitor, you need to wrap your head around and control. So a lot of people think if they choose a single cloud, we'll talk about this in a little bit more later, but if you choose a single cloud provider, that somehow is inherently more secure than choosing another cloud provider. Well, if I just go with Amazon Web Services and I put all of my eggs into that basket, I can make sure I can more easily get my head around the problem and wrap my arms around the problem and make that more tractable from a security standpoint. That's tempting, it really is. But oftentimes, those single cloud providers might not meet all of your requirements. They might not meet all of your needs from a cost perspective, from a scale perspective, from an availability perspective. And so, again, that's tempting, but it's not always feasible to do that. And the joke there is that Active Directory and LDAP are not going to save you now, right? In the old days, we used to think, okay, got my Active Directory forest, I got to join someone to my domain, I got to join this machine to the domain, and yeah, I got this domain forest, it's going to be great. If you're not in here, you're not part of the cool crew, that's my security boundary, my Active Directory forest. But that's not really going to help you here in the cloud-native landscape. Let's revisit that concept of the firewall. So I said in traditional large-scale system architectures, in these large data centers, you had a nice wall you could draw around the data center. You had a firewall that protected ingress and protected inbound traffic of malicious actors, protected your systems from that. And that used to be the standard way of doing things. Cisco ASA, Aruba, whatever. You had these firewall appliances that were your first line of defense. But they're meant to segment networks based on different security levels. Okay, so how is it that I can say that, my cloud or, my regional network in Germany has a different security context than my regional network in, North America? It's difficult to sort of draw those same lines of saying, okay, well, this is most secure, least secure, and tiered system like that. It's difficult to do that in a cloud context. And so without implementing something called virtual private cloud or VPC, the lines between what is internal, what is external, and what is the high security, what is the low security, what is the maximum security becomes really blurred. It's difficult to, again, draw those nice clean lines between your network segments. Storage of data. Okay, this one's big because now we're talking about data in the context of customers or clients. If you are engineering systems that will process PII or medical data, HIPAA data, the importance of securing that data, knowing where that data is, and being able to prove that is a really big deal these days, and it's becoming more so given what we just learned about, the Gartner quote about those cloud security mistakes where the client, meaning the users of the infrastructure, are going to inappropriately share that data, right? The easy question in a cloud architecture is, where are your hard drives? As I mentioned, the old adage, it's not the cloud, it's someone else's computer. That hard drive is somewhere. Is that hard drive protected? It's storing your customers, your clients' sensitive personal identifiable information, your credit card numbers, addresses, all of that. Is that hard drive secure in the sense that I can't walk into a data center and walk out with those hard drives in a bag? How do you know that? How do you prove that? In the absence of that proof, how can you guarantee that if that happens, that someone walks out with your data, that you're secure, that the data on those drives is secure in some way through some confidentiality, some type of encryption scheme? These are all important things for securing data and storage of that data in the cloud. So you see, I use the example of GDPR. This is not really appropriate for North America. This is a European Union standard for the General Data Protection Regulation, but we have things similar to that here, obviously, in North America. HIPAA, FIPS. There are a lot of things in the government sector, in the federal sector, or the healthcare sector where we have these standards or these certifications that we have to meet for the storage of that data. Databases. So even, I would say, more important or more critical a feature for cloud infrastructure than the actual data storage, the underlying data storage, are the use of databases. Databases are ubiquitous. Everything uses a database, right? There are LAMP stacks and MERN stacks, using MongoDB and Postgres and MySQL and MariaDB, and you see some offerings here. Database as a service. A cloud service provider says, hey, we'll run the database for you. You just have to pay us tens of thousands of dollars every month, but we'll run that database for you, and you can just put all your data into our database that we're hosting for you and give you a service level agreement for that database. Guess what goes in databases? Credit card numbers, PII, social security numbers, all the sensitive, indexable, searchable data goes into databases. It isn't just stored, in most cases, on a hard drive or in an S3 bucket. It's stored in a database. And so databases are often the target of 0 days. these zero-day threats, these vulnerabilities that don't have any known mitigation against them. Database software is one of the top targets for those types of vulnerabilities. And so because we want to look at it from the lens of, okay, I'm storing the most sensitive stuff in this database, and it's the most likely target for malicious actors, that's probably a place I need to focus, and I need to look, really carefully at securing those databases. And the last bullet there is, I think, especially important. Not just 0 days, right? That's the real hacker, serious black hat stuff you see in the movies, where we're actively exploiting this software because it has an unknown vulnerability. But if you have some sort of credential leak, which is, back to that quote from Gartner, that's usually the cloud security failure you see the most. There was an interesting statistic from GitHub that over the last 5 years, they have seen millions, and I thought that was a mistake at first, they had seen millions of leaked credentials in GitHub repositories. This was developers, sysadmins, DevOps engineers committing a password, a secret, some sort of credential for a database or some type of server credential and pushing that to GitHub in a public repository. Millions. I was staggered by that. Millions of passwords are just out there. And again, public GitHub, you know what you can do with public GitHub? You can just scrape all the repositories and pull all the code out. And if you're a really smart script kiddie hacker, you're just looking for password : something. Password equals, passphrase equals, encryption key equals, right? That's gold mine to you. And what are you going to do with those credentials once you get them? You're going to go and find that exposed MySQL database endpoint that you found from a company because you web scraped them and found that they didn't secure their MySQL database endpoint, and you're going to try to use those credentials to get into that database. So it's kind of a two-pronged attack. You have the 0 days and kind of a, I don't want to say honeypot because that's more of a defensive type of application, but it's definitely an attractive target for both vulnerabilities and credentialed exploitation. And so once these malicious actors have that data, once they've taken the PII, the new thing now is ransomware. That's the big one, right? Where instead of trying to go on political smear campaigns or taking the data and embarrassing people, doxing people, revealing their identities online, what do? They email the clients whose data they now have and say, hey, we have this really embarrassing data, or hey, we have your credit card information or your social security numbers, and what we're going to do is if you give us this much Bitcoin or if you give us a certain amount of money, we'll give that back to you. So unfortunately, who's most at risk here are these clients of sensitive data and not the actual businesses themselves, unfortunately. So all these things we're talking about, data, databases, networks, what do these comprise? These are now, I've kind of put the fear into everyone about all these vulnerabilities and the, sky is falling, Chicken Little moment of, okay, these all sound terrible, and have we really given a lot up from moving from the data center to going to the cloud? Have we given up all these opportunities for security? And how can we kind of wrap our heads around that and make that problem a little bit more manageable and tractable? And I think the starting point here is the pillars of information security engineering. So the first is confidentiality. The second, integrity. And the third, availability. The CIA model, not to be confused with the Central Intelligence Agency, of course. Confidentiality, integrity, and availability, kind of the three pillars of modern InfoSec engineering. These are kind of focus areas where we can say, okay, I want to address each one piece by piece, and so that I can cover all of my bases. You don't have to attack all those problems at once and from sort of, a really haphazard way. You can say, okay, I'm going to cover my confidentiality bases. Okay, now I'm going to cover my integrity bases, and now I'm going to cover my availability bases. Are you going to get it right out of the gate? No. I won't even say maybe, because the answer is no, you won't. You won't get it right out of the gate. But this is a good starting point. So confidentiality, integrity, and availability. Confidentiality applied to all your data, applied to communications. So communicant A to communicant B, TLS, transport layer security. I'm using a VPN. I know, JHU probably has some sort of VPN software. If you're at home, you can VPN back into Johns Hopkins, access the intranet, right, with all your corporate resources there. That's a form of confidentiality. You don't want that traffic being sniffed across the internet and them, seeing the secrets of Johns Hopkins University. Integrity. Can you verify that you are talking to the entity you think you are? Can you verify the data you're being sent is the data that you requested? If you've ever downloaded an operating system, ISO, an operating system disk image, if they're worth their salt and they're an actual serious operating system distribution, they're also going to supply with it a SHA hash, a SHA sum, right, a checksum of that ISO file, so that when you click the link and download it, you can also click and download that fingerprint or that SHA sum, so that you can do that verification yourself and say, hey, I'm going to go ahead and use MD5 and hash this file, and if I don't get the same value that they're providing me, then I know that this file is either corrupted or been messed with in a way that I don't really want to install it, right? Availability. Do you have a service level agreement? I talked briefly about that a moment ago. SLA, 4 nines, 5 nines. What's the amount of downtime that we can tolerate every year, and how much is that going to cost us? 4 nines to 5 nines, that's what, 8 minutes to 8 hours, something like that. That's ballpark. Huge gap between 4 nines and 5 nines. And subsequently, probably some extra zeros on the check to get that kind of availability. Will your data be available on demand? And can you survive catastrophic failures of one of your critical components? This is, as we'll see later in a later slide, this is something that is often overlooked, right? All the security stuff in the world, whiz-bang, confidentiality, cryptography, state-of-the-art, quantum, all of that is useless if I pull the power cord out of your server, okay? The availability is part of your security posture, because if you have a critical service, like in a medical field, and you're serving critical patient data, and you need that data to be available to your patients and to your providers at a moment's notice, if it's not available, that could cost someone's life. That's about as high as the stakes get. And so availability is part of these 3 pillars, and I think is one of the most overlooked of them of all. So let's talk about solutions. So now we said, here are the problems. Here's the framing of those problems through the 3 pillars: confidentiality, integrity, and availability. Let's talk about solutions. All right, so what you see here, and again, this is one of those, I don't really mind if you can't read the little boxes. This is a tiny little snippet from the CNCF, the Cloud Native Computing Foundation's landscape map, which is a fascinating thing to look at on the website, on their website. I would encourage everyone to go to cncf.org and look at the Cloud Native Computing landscape. It's an interactive thing. Zoom in, zoom out, click on all the little boxes. And these are all sort of Linux Foundation, Cloud Native Computing Foundation projects in different focus areas. And I've zoomed in. There are over 10,000 cards on this landscape, by the way. I've zoomed into security and compliance. And I can't count, but I'm going to say 75. There's a lot of boxes in that little box. So you just pick them all, right? If you apply all of them, that's probably the best, right? Because a lot of security is good security, I think, right? No, I joke, but this is just an illustration of the problem, what they call paralysis of choice, or the paralysis of indecision. It's that Netflix problem. So much to watch, I can't pick anything, right? Here, there's so many options, you're kind of paralyzed because what if I make the wrong choice? What if that company turns out to be, SolarWinds again? Remember that one? Yeah, this guy's shirt matches the color of the slide. You're welcome. I thought that was very awesome. I told you, once I found these, I had to use them everywhere. So this is my friend here, the security engineer. He's just been tasked with choosing the right security solution for Acme Corp, and we gave him this postcard here and said, well, don't make the wrong decision. You know, the whole world's counting on you. Good luck. But before we talk about engineering solutions, I'm a tinkerer, I have a home lab, I run a blog, I do a lot of stuff. I love to tinker, I love the engineering part, I love drawing boxes and lines on a whiteboard, as we all love boxes and lines on a whiteboard. But unfortunately, you can't really engineer anything until you have your policy under control. Because what are the standards to which you are securing your system? What are the milestones? What are the bars that you have to reach? What is the minimum level of security that you have to achieve? How do you know any of these things if you go into the problem open-ended? That's why you have to have policy before engineering. That's one of the most practical and actionable pieces of advice that I can give folks out there, and that is policy before engineering. You have to have policy before engineering. I hate that because the policy people, they're my favorite people because they're always saying, don't do this, do that, don't do this, do that. Well, this one's fun. I want to do this one. You can't do that. It's insecure. Okay, great. But seriously, looking at this policy problem, I think is a little bit intimidating at first. And there is a tendency, at least in some circles, to do what we call traditionally a waterfall or a big bang development cycle or a establishment of this policy where, well, here's what we're going to do. We're going to write an 86-page white paper. And it's going to have system shall, system shall, system shall about 4 million times in those 86 pages. And we're going to figure everything out. Everything in that policy document is going to be perfect. V1, day one, we're just going to apply that to the system, and it'll be good. Because we can solve all the problems before we even implement. And I think in the cloud context, in this cloud-native world, where we're working in these environments that I've described, you can build the ship underway, as I say. Start small and then build, right? Establish good policy and build on that good policy. Don't establish one giant bad policy and then try to reverse it all and then make good small policy decisions, because you're going to end up there no matter what. You can't do it all at once. Definitely give yourself room to grow. Make that policy part of your code base. Policy is code. So if you work with developers, if you're developing applications, business logic software, you know that you have source control repositories. I talked about GitHub. You might have a Bitbucket or Mercurial or whatever, Subversion. But that's where you keep your application code. That's where you keep all your container images. It's where you keep all the stuff that makes your business your business. But I would also say that policy belongs there too. This is a kind of a novel approach. I think it's kind of become de rigueur in the last 4 or 5 years to treat policy as code, because more and more solutions are becoming available that allow us to keep policy as code. If I have a repository where, all of my policy is in a human-readable markup format, let's say YAML, JSON, one of these things that's kind of easily human-readable with key-value pairs where it says policy name, policy rule, permit, deny, true, false, yes, no. I then can take that policy and make it, give that to my security team, my DevSecOps team, and say, you own this now. This is your policy as code. You write all the policies in the code, and then you give the people who are executing, the engineers, the DevOps engineers, not the developers. If your developers are touching your policy, you've made don't pass go, don't collect $200. That's a bad idea. But you give that code repository with read-only permissions to your engineers, and they can execute that code. And so you have what we call separation of concerns, where the people executing, delivering the infrastructure, the SREs, the folks doing the work, don't actually write the policy. They apply the policy. The policy people write the policy, and they source control it in a way that's transparent to the people doing the work. So it isn't, did you read policy document on the Confluence page? Did you read that? Yeah, apply that policy. Don't do it wrong, even though I don't really understand it, but I wrote this sentence that kind of vaguely describes that I want you to secure the network with some stuff. So there's some options. If you're doing Kubernetes, there's Kyverno, Open Policy Agent Gatekeeper. AWS has their policy generator. GCP has IAM policy. We'll talk about IAM in a moment. But lots of options there. So policy before engineering and policy as code. I think those are two good recommendations. Now let's get back into the solution space, confidentiality. I hate doing this. Webster's defines confidentiality. But I think it's important here, the state of keeping or being kept secret or private. Because we're talking about, again, important data, critical data, user data, PII, social security numbers, all of that. Encryption, cryptography, isolation of sensitive data from non-sensitive data. I would say in 2022, you have absolutely no excuse to not encrypt your data at rest. If you are storing data at rest on a hard drive, in an S3 bucket, in a database, almost every solution out there has an option available for you to encrypt that data at rest. It wasn't so long ago that was actually a consideration from a compute standpoint. It's too expensive to do the encryption because there's a lot of overhead, right? If I encrypt my data, it makes it slightly larger. It expands on the file system. Or to encrypt that data at such a large scale is costly in terms of CPU and memory utilization. So there used to be a consideration about, do we have to encrypt everything? But now I think in 2022, it's kind of a foregone conclusion that if you don't encrypt your data at rest, you're opening yourself up for some problems down the road. Options here, file system encryption using a product like VeraCrypt, object level encryption, so S3, MinIO, these are types of bucket storage, object storage. I want to put arbitrary file A into my object store. You can encrypt that on its way into that object store before it ever hits disk. And then the sort of big dog, the low level, block level encryption. That's disk sectors being encrypted with something like DMCrypt, device mapper crypt. That's sort of Linux file system block level encryption. So we have different types of encryption: at rest, in transit, and in use. I'll go to the bottom first, and then we'll go back up to the top really quickly. Don't write cryptographic libraries. Don't write, hey, here's a little bash script that's going to call this Python script that's going to encrypt all my cool data files and then put it over here. You're going to implement it in some way that, per the RFC or per the man page, is going to make it useless or really easy to reverse. So don't roll your own cryptographic utilities. That would be my biggest piece of advice. There are folks at universities, big think tank research groups that wrote all of those libraries like OpenSSL and OpenSSH. Yes, they have vulnerabilities every once in a while, but they're way ahead of what you might roll if you roll your own. So please don't do that. At-rest encryption, again, FDE, full disk, PGP, pretty good privacy. Interestingly, that's kind of giving way now to something called AGE, as Mozilla, very popular with the Mozilla folks. AGE using a utility called SOPS, Secure Ops or Secret Ops. In transit, so this is just securing your communications. Every time you visit a website on the internet, this should be, this is kind of elementary, my dear, but it should be said. When you visit a website on the internet, you now see that little, lock, that little padlock in the top left of the address bar saying, hey, this site is secure. If you click that little thing, it'll drop down and you can look at the certificate, the cryptographic identity of that website or that server that you think that you're going to. Right? You can verify that through some third party like VeriSign or Venafi. Again, as I said, VPN is another option as well. In use, I'll just briefly mention in-use encryption. This is kind of new. You have Intel SGX, that's secure guard extensions. That's data is secure while being processed by the CPU. So as it's going from CPU register to volatile memory, it's encrypted the whole time. Right? So executing code can be encrypted. So it used to be that you could encrypt it when it's sitting on disk, but when you need to use it, you have to decrypt it to use it. Now the CPUs, so many transistors, they can dedicate some of these transistors to doing this type of in-use encryption. So Intel Secure Guard extensions are really cool. AMD has Secure Encrypted Virtualization, SEV, or SME, Secure Memory Encryption. And this is a similar concept where volatile system memory is given a physical key from the CPU passed around the operating system, right? So the operating system never has use of that key, but that key is being used to encrypt the memory of the system while it's in use. So those are some interesting things that are kind of currently being leveraged. I think Microsoft Azure is one of the leaders in this space. If you go, you can Google Azure, Intel SGX, confidential computing, and they have white papers and how-tos on how to implement this in Microsoft Azure in their cloud. It's very interesting. So what I struggled with the concept here of shouting out or calling out a product. This is an open source product, and the other one that I'm going to suggest to folks is also an open source product. I have no financial connection to these companies. I have simply, with my team and over the years, I've used this product in particular, and the other one you'll see in a moment, Keycloak. And these are awesome products. So this is HashiCorp Vault. Vault is just a secret storage engine. It's way more than that. Obviously, if the folks from HashiCorp were here, they would say, you're underselling it, Evan. But really, I want to talk about it from the sense of secrets management and key management and this type of thing. If you're going to start securing your systems by applying cryptography, you need keys to do that encryption. Where do you put the keys? There's a program called SPIFFE. It's the Secure Production Identity Framework for Everyone, SPIFFE, that was started with Google and Netflix, and all the FANG folks got together, in the big cabal, and they said, we need a way to do identity and encryption, mutual encryption and zero trust everywhere in the world. It has to be free, it has to be open source, and they came up with SPIFFE. And they kind of coined this term, or they have a ebook called Solving the Bottom Turtle. Because if I have a key that I encrypt my data with, and I put the key in my secrets engine here, which is encrypted with a key, which is then, right, it never ends. So you have to solve that bottom turtle. And I think HashiCorp and Vault, with their Vault product, is helping a lot of folks do that by allowing, sort of this really diverse secret storage engine that allows you to store arbitrary secrets, PKI, database credentials, you name it. So I would encourage folks to check HashiCorp Vault out for the confidentiality aspect of cloud-native security. JIT, just-in-time database credentials. So if your application needs to access a database to get some of that sensitive customer data, it has to go to Vault in that moment to get its credentials. Well, guess what? What if the authentication method that application is using has been revoked because it was detected to be malicious or compromised? Well, now I can't get into the database. That's better than hard-coding your database credentials into your code, and then there they are. And if they're compromised, they're compromised. Integrity. Internal consistency or lack of corruption in electronic data. So integrity, things like identity, code integrity, data integrity, non-repudiation. Right? Non-repudiation, can I be certain that the person sending me this email is that person? They cryptographically sign that email and they say, I see the little red badge up in the top that says, yes, this is cryptographically signed by Joe Schmo. That is integrity, right? Part of integrity, I should say. So identity and access management. In the cloud-native space, this is kind of one of the biggest, I would say, factors to securing infrastructure, because as the name implies, it's establishing identity. So we have an authentication part, and then we have access management, which is an authorization aspect of this. So I have to establish the person is who they say they are through some sort of challenge and response, username, password, two-factor authentication with your phone, what have you. And then the access management part is, now that I've established you are who you say you are, what are you allowed to do in this system? So identity and access management is huge. So all of these cloud providers, AWS, GCP, they have sort of wide-reaching, multi-tentacled, overarching identity and access management systems that effectively control their entire platform. And what they want you to do is, and I think it's a very effective solution, this is not in any way a diss of that system, is your people, right, your engineers, your developers, your security folks, even your HR folks have some function to perform. And all of your non-persons, right? All of your automation tools, all of your systems have to go through that identity and access management plane before they can access any of the systems. And so it's sort of the one-stop shop, the one point of entry to your systems. So if you think back to when we talked about the old data center where I had a firewall and that was my single point of entry. And if someone was inside that firewall, well, they're a trusted person, right? Identity and access management is effectively that kind of new firewall. Not in the same context, of course, not in the context of networking, but it's the one place I go to from an audit standpoint to make people accountable, to check on what Joe Schmo developer is doing in his off time. He keeps trying to log in as root everywhere, and it keeps saying he's denied. Maybe we should talk to him. Well, let's just fire him. So identity and access management. Options for IAM. If you're on a provider, again, AWS, GCP, Azure, they all have identity and access management solutions, one-stop shop for everything, and they're very effective. Third party, OIDC, that's OpenID Connect. It's an open source protocol for this type of identity provider. SAML, GitHub, GitLab, LDAP. You might see if you go to, there are a lot of popular web platforms where when you hit the website, it says log in with Facebook, log in with Google, log in with Amazon. These are all identity and access management tools. This is single sign-on and identity providers. So that website or that service that you're visiting trusts that Google is going to establish that you are who you say you are, and then they're going to move that identity or pass that identity over to this service or this website that you're visiting, and once you've established that. And single sign-on, Keycloak, which is another product that I'll make note of here. Keycloak is an open source identity and access management and single sign-on software, again, free and open source. It supports federation, strong authentication, user management, and fine-grained authorization. So this is kind of a one-stop shop for an open source product that effectively is comparable to those AWS, GCP, and Azure identity and access management solutions. If you are multi-cloud, if you have infrastructure in Amazon, if you have infrastructure in Google, you can't, guess what? You can't use Amazon's identity and access management tools in Google Cloud Platform because they're pretty walled garden-y about that whole competing vendor solution thing. They don't like that very much. And so now you're forced effectively, if you're multi-cloud, if you're in different vendors, you're forced to use some third-party solution. So I think Keycloak is a really good solution. Again, free and open source. Let's talk about code integrity really quickly. This is, again, not important that you get all the little minute detail off the slide, but this is a CI/CD pipeline, a continuous integration, continuous delivery pipeline. From left to right, you start with your code. You've got your Git repositories. You've got tools, your artifact repo, your testing. You've got and then your actual container images that might be produced out of that testing, and then your deployments all the way on the right side. Hey, look, databases again. I like that this diagram has red and green, because red is bad, and green is good. So we started with, man, this is so cool, left to right, the arrows go from the left to the right, and we just deploy our software, and it's just wonderful. It's just left to right, CI/CD, code integrity, wonderful. Well, at every single one of those points, something potentially bad could happen, like a code injection in your repository, right? Malicious code. Some malicious actor from, Zyklon B commits to your source code repository, and your automated process to accept those pull requests and merge them into main triggers a build, which triggers a deployment, and all of a sudden, that malicious code that's been committed deep into your C++ repository is running in production, stealing all your user data. I say this not as sort of like hyperbole. That's happened. This has actually happened. Again, build tools, expose credentials. I mentioned this earlier on in the presentation. Millions of credentials in the last number of years on GitHub have been exposed by improperly, admins or developers improperly pushing those credentials into repositories. And it goes on and on and on. So code integrity is of paramount importance when there's so much code in the world today. Everything is code. This is running on code. You're accessing this through Zoom. Those of you out in TV land, that's all code. Okay? It's running on your local machine, your laptop, your PC, and if someone maliciously put a commit in there that exfils user data off of your system, that's a big deal. And it probably went through some sort of CI/CD pipeline, just like you see here. So this is a really big deal. Code integrity is becoming more and more important and more prevalent as one of the top things that organizations are looking at when they're talking about cloud-native security is code integrity. And last thing here, availability. 2 is 1, 1 is none. It's an old Army thing, right? If you're not early, you're late. That sort of thing. Again, if I pull the cord on your server and you only have 1 server, then you don't have a server, do you? If you have 2 servers, okay, maybe get 3 servers. It's a game of numbers, really. In the cloud, this is why I think a lot of people get confused about that question, should I be multi-cloud? Well, how much failure can you tolerate? If you are only on Amazon, if you're only on Google, it is very unlikely that they're going to have some sort of catastrophic global outage. It has happened, and usually it's DNS or some BGP failure in China or something. But again, that's one of those things where that's part of the availability discussion. Maybe being multi-cloud, multi-vendor is part of your availability posture. COOP, continuity of operations. Those in the federal sector and the government sector, we get talked about COOP all the time. Where are we gonna do this particular important business function if this building gets blown up, right? That's an actual reality that we talk about. So being multi-region and having failover is important. And the last thing there, scale. It is not your fault if you run a tiny little web blog on a T2 micro instance in AWS and you become internet famous for some meme on TikTok and they give what we call the hug of death to your little mini server there in AWS. It's not your fault, right? You can't blame someone who just had their little blog out there. But if you're a business and it's your job to have your data, your services available to your customers and your clients, it is part of your availability posture to build in scale, so automatically scaling. So things like serverless functions. AWS has Lambda, Google has Google Cloud Run, I believe. These things are new, whiz-bang serverless. That's a often, I think, overloaded term, but what does it mean? It means something happens on demand based on scale, based on load. If 10 people visit my website, I have one of these functions running. If 10 million visit them, it will automatically scale up to 1,000 of these functions, and it'll handle the scale. Now, again, they're going to charge me for that. That is not free in AWS. That is not free. But that's part of scaling. So again, availability needs to be part. That's that third pillar of the CIA sort of triangle, or the stool, I guess, right? But yeah, availability, very important. Last couple slides here. Certifications, accreditations, and compliance. I mentioned these throughout the presentation tonight, and what I think of these, a lot of people look at them as onerous, these big wigs telling me how to run my system. They're like a security blanket, pardon the pun, for me, because it's a reference document. I can say, okay, we need to be SOC 2 Type 2 certified. Let me go get that white paper or that certification from this year's current revision. Do we have this? Yes. Do we have this? Yes. It becomes your checklist. It becomes your Bible. And so if you're in an industry where you are sort of required to abide by and be compliant with some of these certifications and accreditations, I think that's a positive thing because you have a target. Otherwise, again, back to the policy as code discussion, it's open-ended. Where do you stop? Where do you start? What's good enough? What's secure enough? Well, these organizations have kind of taken care of that for you. So you have FedRAMP, Fed obviously for the federal government. You have SOC 2, HIPAA for the medical industry, FIPS, the Federal Information Protection, and GDPR, that's for European folks. Some additional considerations that I didn't include in the slides this evening. I did. I had them. This was going to be an 80 slide presentation, and I was like, maybe I should cut it down, Evan. And so each one of these could have been a whole slide in itself. But again, certifications, accreditations, and compliance, as I mentioned, cost. I have talked about cost very briefly, but that's usually what you lead with, right? This is really expensive, but here's why we need it, right? Open source risks, software supply chain, those go hand in hand. I mentioned that malicious commit that got into your source code repository and made it to production is now slurping user data back to Zyklon B. That's the software supply chain. It's really, really important now. I mean, you're hearing a lot of it now because of things like SolarWinds and Log4Shell, Log4j, right? How did those all get in there? And how can we guarantee in our systems as we pull in all this third-party code? I've just recommended to you tonight software solutions. Are those completely immune to any of these vulnerabilities that I've talked about? Absolutely not. But it's on these organizations, it's on your organizations and your security and engineering teams to do that type of vetting and validation. And there are some tools like Salsa, ChainGuard, interesting tools out there that are kind of coming to the fore now that are providing these certifications, if you will, for the software supply chain, where they're providing artifacts, signatures, bill of sale almost, or they call them an SBOM, a software bill of materials. You ever done a BOM to order some servers? It's my bill of materials for my servers. Well, now we have SBOM, software bill of materials, so that if I'm going to run this software on my cloud infrastructure, I can look at a manifest of everything that's in it. Okay, what dependencies did you pull in? Oh, Python, this thing, cool. I know that. I can look up the CVEs and the STIGs for that. And so SBOMs are very, very interesting, and I think you're going to see a lot more of those as time progresses. Separation of concerns. The people implementing your security policy should not be the ones writing the policy. Because if I'm the guy with root and I get upset, I might do something malicious. Well, the policy people should have the guardrails in place so that that person can't do that. And lastly, edge compute. I mentioned very, very early on in the presentation here, edge compute. That's our third inversion. We're in the midst of that right now. That will become more and more, I think, relevant. It's relevant now, but I think you'll see more of it as, I like to joke, as your refrigerator becomes self-aware, right? As they put a supercomputer onto your refrigerator and it starts, doing machine learning and AI inference on the half-drank jug of milk in your refrigerator, this type of thing is going to become more and more important, and securing these edge systems will become more important as well. Because now it's in your house. Now it's, what if it spoils your milk maliciously? It'd be terrible. So just some final thoughts before I end tonight. Good security engineering isn't about silver bullet security software. Well, Evan, you just told us about some software. Just suggestions. Remember that Cloud Native Computing Foundation little card that I showed you? You zoom out on that thing, and the options are endless. So again, you have to make those decisions yourself. It's not just one size fits all. Although I do believe there are a lot of companies out there that are pushing these solutions that say end to end. We got you from code to deployment. Literally every part of your CI/CD pipeline, your deployment, and your scale, we got that. I would be hesitant to recommend software like that. Fundamental organizational changes can help move any additional security practices forward. So as you add these things, that's why I said do the policy as code piecemeal. Start small. Because if you come in, swoop in and say, hey, we're doing everything wrong, we're engineering insecure systems, here's my cool white paper, we should do all of this today, that's not going to be accepted very well. No one wants to say, wait, we're doing all this right now, we have to change everything at once. Incremental, right? Incremental organizational changes, I think, are important there. Awareness training, documentation, there's a human factor here. If I engineer the most secure, performant, highly available system in the world, and my system administrators go about administrating that system using poor security practices because they weren't trained on how to do it the correct way, now there's a human element that's the vulnerability, right? They are the vulnerability. My people are the vulnerability. Just like physical security is short-circuited the most by people, right? That door has a lock on it. If I open the door and then chalk it open, Well, that's a person problem. It's not the door. The door isn't broken. I just left it open because I didn't know I was supposed to close the door. So awareness and training, very important. And the last thing here is automation, automation, automation. If nothing else, if you take nothing else away from this lecture tonight, I would hope it's that this is a complicated landscape. This stuff is not simple. It's not trivial. It only got worse. It was already complicated, and now it's worse. And so how can we ever hope to expect humans, right, however brilliant or rock star, we have sysadmins, system engineers, developers, however smart those folks are, they make mistakes. And implementing these really complex systems and trusting humans at every step of the way, it's only going to lead to heartache, right? It's only going to lead to an insecure system. And so deciding how you're going to implement something and then automating that process is the only way to go. Again, CI/CD pipelines, this type of thing. They call it DevSecOps pipeline now. You got to put sec in the middle of DevOps. That's the good way to go these days. So again, automation, automation, automation. And that's it. Thanks everyone for listening. I'll take questions. Clinton, is that right? I'm taking questions?
Yes, you are taking questions. So hopefully we have some.
If we have any.
Evan, hi, I have a question for you.
Sure,
When you're
go.
talking about separation of concern, is that the new terminology for segregation of duties? Or are those two different things?
Hi, Josie.
Hi, Evan.
That's a great question. Thank you for that question. Yeah, I think we're on, I think that those would be roughly equivalent now. It's the same as saying, your management is separate from your operations. Your, security is separate from your operations. These are the separation of concerns because you don't want to have one organization, right? You have some sort of big team who has all the keys to the kingdom, and they write the policy, and they audit themselves, and right? You can see where this kind of leads because you don't have where they you don't have an auditor auditing the auditor, whatever they call
Right.
it.
Right.
Yeah,
Okay.
So, yeah.
I just wanted to make sure. Thank you.
You're welcome. Thank you.
Anything else? Any others?
This was really good, Evan. Very informative. Thank you. It was a lot of information, but it was really informative.
Yeah.
I think the slides will be available, Clinton, is that right?
Yes, so the slides will be available, the video will be available probably within a week, I estimate. You go to our webpage, you'll see an after-action report that has the slides and some commentary, and then that will link to our YouTube channel where the video will be, or you can just go right to the YouTube channel and watch the video. So, any other comments or questions from the group? One thing I want to do, if there aren't any, but if you have some a little bit later, feel free. I want to offer Evan here our chapters. Thank you.
Oh, great.
And we got
Thank
a
you.
little- That's our sort of official formal
Oh, this is awesome.
certificate. You can hang that up in your
I will.
bedroom.
Or my office,
No, yeah.
Or my office,
And
I
then
guess.
And you can have that mug on your desk.
I'm going to put them.
Yes.
I'm going to put them both on my desk in a place of pride, certainly.
So this is Incose's traditional caffeine delivery system.
Oh, excellent. Well engineered, I
Right.
hope.
Yes.
Well engineered.
Excellent.
So
Clinton, thank you very much.
for the talk.
Thanks, David. Thank you.
And this will conclude.
Okay, this is Kaz. I do have a question.
Go
Oh,
ahead,
great.
Kaz.
I noticed at the beginning of your talk, you had this nice reference architecture and showed the landscape. Is that fairly complete what you've shown, or is that a, like an 80% version of what's there and there's a lot of new stuff?
So I'll be honest, that reference architecture, I think the date of that is 2017, if I'm not mistaken. So as you know, things move really quickly in this field. So I would use it as, a jumping off point. But again, that was a reference architecture for, the data center, the traditional data center, and a little bit of the public cloud infrastructure there. But I really was just using it to scare folks. So take from it what you will, but you should visit Network Bachelor. That's where I got it. It's really great. He has lots of reference architectures.
Okay, then I guess most of the stuff that you were talking about really was more cloud
Yes,
environments.
that's right.
And
That's
okay,
right.
so now, I guess what I had was the idea that as you went through the CIA aspect, and each one had its own, say, flavor for what it was doing for you in that cloud environment. Is there somebody tried to do, say, a mapping of each one of those items onto this reference architecture and say, like a big Venn diagram, so to speak, with various layers? Here's your C layer, here's your I layer, your A layer, and say, this is all the things you're going to be covered by these different pieces.
Yeah,
Does that sound, I mean, I don't know, I don't want to give you more work, but this sounds like you could probably write
are you ordering that? Is that something, picking off the menu? No, I think it's a great point, and I think in different forms, the answer to that question is yes. And I think it's yes in the context of each one of them taken by themselves, each one of the pillars, confidentiality, integrity, and availability. There's probably a number of overlays that you could put onto that system reference architecture and highlight each one of the items that fits the confidentiality pillar, right, or that serves that pillar, the integrity and the availability pillar. I think it'd be difficult to kind of represent all of that in one graphic because really it's, as you quite rightly point out, they're layers, right? If you looked at it all together, it'd be a sort of a mess, but if you kind of peel the layers away, you have at the base your confidentiality, your integrity, and then your availability on top of that.
Okay, it's just then, that way when you're trying to explain this to someone, you can show them a little bit more pictorially or graphically to say, here's your areas of concern and this is what gets covered by each one of those, or even segments of it, because see for the C layer, you did have 4 or 5 different parts of that. And, it's not that each one wasn't comprehensive, it just was a different piece or a different area.
Sure.
And that's what I was saying, that you could, at the C level, you could have like 5 or 6 different, circles. Some of them obviously, cross themselves or something like that. But at the same time, there's others that, only cover one spot and the other spot isn't covered. So that's all. It was just something that, you might be able to then look at that and then treat it, because then you say, oh, wow, this is really weak over here. We only have this one thing protecting this particular entry point or something coming into your network or your domain there that you're trying to work with.
Yeah, no, those are all great points, all agreed. Yeah, I think this was a primer, so I think maybe that would be the deep dive, right? That would be the deep dive lecture. I think something we could cover there, but maybe another time.
Well, okay, then has Clinton been poking you as well about doing this tutorial or some sort, one of those Saturday type events? So I'm not certain. I mean, I always, I look at this and yes, there was a lot of material. I mean, that was just, I'm like, wow, you don't realize how much stuff there is until you talking like the Federal Express guy in the commercial, 700 words a minute, and you got done maybe in an hour. Now we're like, okay, can we go just a layer deeper? And then I might take a 4 or 6 hour tutorial on a Saturday and at a location.
That would be awesome, Evan. I would be all for you.
I try not to work
doing
nights as much as possible.
Yeah.
But Kaz,
But here we
I
are.
was thinking about the SysML, the Agile SysML tutorial that we just had. The things that he was talking about last week, that 7-hour tutorial we had, and using that technique to map some of the things that Evan was talking about to the CIA, to the confidentiality, integrity, and availability pillars, right? I think that would actually be a great exercise.
Okay, so you're talking the Agile LSM with
Yes.
Mike Tappert?
Yep. That's what popped into my mind.
Well, I guess the
To
thing is,
try to wrap your head around this, right?
Oh,
Or
okay.
that's what I'm thinking about.
Oh, I see. So therefore, if you're coming up with a new system, you go through these various aspects of, setting up a cloud environment of some sort. Then
Right.
Your LSM methodology to
Right.
you've been, covered all your policy methods. Well, actually, what we probably should do is ensure that, I don't see Mike online here, make certain he sees this. Maybe we can work with him to come up with a,
I think that would be cool.
you know,
What
and
do you
maybe
think?
combine it or something too with.
Right. I think that would be pretty cool.
Yeah, okay.
All right, guys. Well, we'll look into it. I'm going to go to, are there any other questions before I
Yeah,
move
hey,
on?
Clinton, Dave Faley, got a question for you.
Okay.
Yeah, hey, Evan, maybe I missed it. Did you talk about zero trust and its impact on all this as well? Because that's the latest and greatest stuff that's happening.
I didn't really talk about zero trust per se. I did touch on it through, excuse me, mutual TLS. You know, the concept that, and what is, I'm sorry, what was the name?
Dave.
Dave, the question was about zero trust, and that's kind of one of the new buzzwords. What that really means is that in a given system, in a given network, no communicant trusts the other communicant inherently, meaning that I don't have some sort of inherent trust relationship with this other entity by virtue of them being inside of my network. Right? Just because I'm inside the confines of some network perimeter, that doesn't mean that I don't have to put my guard down. That's zero trust in a nutshell. And how do we achieve zero trust? That's a bigger question. That's kind of, you know, when you get in real buzzwordy. But one of those ways is through mutual TLS, meaning that transport layer security isn't enforced, right, for the confidentiality, the cryptographic portion of the communication, but that each correspondent, each communicant, is validating the identity of the communicant. So I don't have some sort of relationship with a server. For example, you visit a website, you don't provide a certificate to that website. So that's not actually zero trust. You are being presented by that website a certificate that says, hey, I'm Mozilla.org or I'm Amazon.com, but you're not like, hi, I'm Evan, here's my cert, right? That's not mutual TLS, that's not zero trust. In a zero trust architecture, I'd have to provide a certificate to Amazon before they would let me access their service to validate that I am who I say I am. So that's zero trust. I think, yeah, that broadly speaking, that is in the, you know, in the confidentiality and integrity pillars kind of quite firmly, because the confidentiality, the cryptographic part is no one that's not Alice or Bob, you know, you got the Alice, Bob, and Eve. Alice and Bob have a private communication that needs to be secured with cryptography, so confidentiality, but the integrity part is identity validation and non-repudiation, as we talked about. So, you know, zero trust is the embodiment of kind of those two pillars, and in practice, really, you see it in mutual TLS. And I think I talked about SPIFFE briefly, the Secure Production Identity Framework for Everyone. That is the entire goal of that project, is to be a central identity provider for every workload in your architecture, every database, every client application, what have you. You give them SPIFFE identities. They just happen to be in the form of X509 certificates. And, you know, there you go. Bob's your uncle. You got mutual TLS everywhere. Great question. Thank you.
All right. Any more? Let me go here. Let me share my screen. So we're going to, can we see that, Bill? Can you share the, I think that's being shared. All right.
I can see it.
So tonight's door prize is a book recommended by Evan. It's called This Is How They Tell Me the World Ends. So sounds like a good nighttime novel here. So I'm going to spin the wheel. I'll reach out to you with the email that you registered with and send you a copy. Congratulations, Pierre. You are a winner tonight. All right. So, if that's it, I bid everyone a good evening. Thank you for coming. And also, sign up for the holiday party if you already haven't.